All right, so in 8.5, we learned about 2 additional quadrilaterals, right? The first one being a trapezoid, second one being a kite. Who could tell me what you know about a trapezoid? Alejandro. So the legs would be if it's an isosceles trapezoid, right? It doesn't have to be that way, right? Just a regular trapezoid has to have the one pair of parallel sides. And then because it's a quadrilateral, we know they have to add up to 360. Those are really the only properties of a regular trapezoid, right? One pair of sides parallel, and then they would all the angles would sum to 360. And then if it's an isosceles trapezoid, now the non-parallel sides, which are called the legs, are equal, and the base angles, which is where those legs, the base angles would be congruent. Okay. What else did we learn about a trapezoid?
The mid-segment is half of the sum of the bases.
Good. All right, so the mid-segment is the segment that connects the 2 midpoints of the sides of the legs, and this would be equal to 1/2 base 1 plus base 2. So 1/2 the sum of the bases, okay? And it's also parallel to the other 2 sides. What else do we know? There's one other thing that you should know about a trapezoid. Morel. Okay, the angles on the legs along the same leg would be supplementary. Yeah. So I lied. There's more than just one other thing. There's something else too. Alejandro.
Mid-segment bisects the leg.
Okay, mid-segment bisects the leg. Do we know anything about the diagonal? Use trapezoid. The diagonals are congruent. Okay, all that was true about trapezoids. And then we learned about what? What was the other quadrilateral that we learned about? A kite. So the kite has 2 pairs of congruent sides, but they are consecutive. So this and this and this and this, okay? Not opposite like in a parallelogram. So this time they're consecutive. And then what else did we learn about the properties of a kite? Alejandro. Diagonals are perpendicular. Good. So the angles where the non-consecutive angles meet. Or non-congruent, sorry. Where the non-congruent legs meet are equal. So this angle would equal this angle. Okay, so lots of properties to add to the list, obviously, okay? And we're gonna, today, the good thing is that this section kind of wraps them all up. So in number 1, we're dealing with what type of shape? An isosceles trapezoid, which tells me that the base angles are congruent, right? So angle C would equal angle B, making this 56. And then these 2 are supplementary, or these 2 are supplementary, or the 4 of them have to add up to 360. I could do 112 subtracted from 360 divided by 2. So there's a couple different ways to get it. But if I just use the supplementary, 180 minus 56, and I get 124. So that's this angle, which is also this angle. Okay, number 2 says find the length of the midsegment of the trapezoid. So we said that the midsegment is equal to 1/2 the sum of the bases. So 17 plus 33 divided by 2, which is 50 divided by 2, or 25. Questions on either of those? Okay, this one's now dealing with the kite. So use the figure to find the indicated measure. Number 3 says if x, y, z, so x, YZ is this angle here is 80 degrees, and XWZ, which is this angle over here, is 48 degrees. Find the measure of angle YZW, which is here. And before we said that what was true about those angles opposite from each other? These would be congruent to each other. So this one would match this one. So if I did 48 plus 80, I get 128. What's true about all four angles? It's still a quadrilateral, right? So they have to add up to 360. So 232 is the sum of the others. Divide that by 2, and I get 116 for both angle WZY, and it would be the same for WXY. Alexis.
Could you also just split like the triangle in half, like divide the 80 by
Sure.
140?
Yeah, so there's definitely 4 triangles going on in there. There's a lot of different ways to look at it. All right, so number 4 says if XO, so if I'm using the same diagram, if XO is 2 and OZ is 2, YO is 6, and OW is 8, find the lengths of the sides of the kites. So what did we say was true about these diagonals? They're perpendicular, which means these are 4 little right triangles, okay? So I can use them in parts. I could say that this is the first one, this is one triangle. So 2 squared, oops, a daisy. 2 squared plus 6 squared would equal x squared or c squared. 4 plus 36 is 40. And then the square root of 40, which is 4 and 10, or 2 root 10, would be the length of this side and also this side, because those are congruent. And then the other right triangle would be here. And I could either use the top one or the bottom one, but I can say that 2 squared plus 8 squared would equal x squared. So 4 plus 64 is 68. Square root of 68, 2 and 34, which is 2 and 17, and I get 2 square root 17. Questions on trapezoids, isosceles trapezoids, or kites? We're good? Good. All right, so like I said, the good news about 8-6 is it kind of wraps it all up. So 8-6 is identifying special quadrilaterals. So now we're working backwards. You're going to get given information about quadrilaterals or four-sided figures, and you've got to figure out which of the quadrilaterals it best describes. So quick review of, we talked about this again last week, but I've got quadrilaterals are all of these, right? The parallelograms would be the big part, rhombuses on the left, rectangles on the right, squares is where they overlap. And now, in addition, we could add on, but they would be outside the parallelogram, a trapezoid and a kite. So these don't overlap because they're different. They're not parallelograms, but they are quadrilaterals. So parallelograms have opposite sides that are parallel, opposite sides congruent, diagonals that bisect each other, consecutive angles, supplementary, and opposite angles congruent. So 5 things we know about parallelograms. Opposite sides are parallel, opposite sides are congruent, diagonals bisect each other, consecutive angles are supplementary, and opposite angles are congruent. In a rhombus, we add that there's 4 congruent sides. Diagonals are perpendicular. And the diagonals bisect opposite angles. all of that is true for rhombuses. And then rectangles had 4 right angles and congruent diagonals. And then squares have it all. All of those properties that are already on that list would apply to squares. And then the trapezoid, 1 pair, parallel sides. If it's an isosceles trapezoid, you'd have congruent diagonals, congruent base angles, congruent legs. And then kites, 2 pairs of consecutive sides, congruent.
This section's kind of like a mashup.
Perpendicular diagonals. And then angles where the non-congruent sides meet are congruent. Okay, so all that stuff that we wrote on that front page or front slide. All that ugly stuff on the bottom could on this slide. Okay, I forgot. I even gave myself another slide and I forgot. So the kites was the 2 pairs of congruent sides, diagonals that are perpendicular, and these 2 angles are congruent. Trapezoid, A and D would be supplementary, B and C would be supplementary. The mid segment would hit the 2 midpoints and be the sum of the 2 bases. And then the isosceles trapezoid would have congruent diagonals, angle E would equal angle F, and angle H would equal angle G. Okay, so now you got to think about it in reverse. If I give you specific information, which of those quadrilaterals is it applying to? And which one does it have to apply to? So it says quadrilateral A, B, C, D has at least 1 pair of opposite angles congruent. What type of quadrilateral meets this condition? So what does at least mean? It could be more than 1. So if it's opposite angles congruent, what does it rule out? A trapezoid. Okay, does that make sense? Because a trapezoid, it says at least, which means it can be more than 1. And a trapezoid, it can't. Does that make sense? Okay. But does that describe anything else? Like a parallelogram, you would need 2. You with me? A parallelogram, you would need 2. A kite would be only 1, not at least 1. Okay. Does that make sense? So the only one that it really can't be is a trapezoid. Everything else it can be, right? Because a kite can have at least 1. A parallelogram can have at least 1. Rectangle, a rhombus, a square, all of those can have at least 1. The only one it rules out is a trapezoid. Does that make sense? Because a trapezoid can't have a pair of opposite angles congruent. Okay? So this could be all but a trapezoid. Example 2 says, what's the most specific name for quadrilateral ABCD? So based on that diagram there, what do you know about the diagonals? They're bisected. That's all we know. I don't know anything about the sides other than that there's 4 of them, right? I don't know anything other than the diagonals being congruent or being perpendicular. Nothing other than that they are bisected. So that's enough information to show that that's what? A parallelogram. If it's a rhombus, I need more information. If it's a rectangle, I need more information. If it's a square, I need more information. So the only thing I can conclude from this is that is at least a parallelogram. This one, is it enough information given in the diagram to show that the quadrilateral is an isosceles trapezoid? So first of all, how would I know it's a trapezoid? So 360 would just be that it's a quadrilateral, right? You got to go more specific than that to make it a trapezoid. What's the definition of a trapezoid? No, that's you're thinking isosceles. What's the definition of just a general trapezoid? One pair of parallel sides. Is there enough information in this diagram to show that there's a parallel sides? Yeah, how? So what's true about angle S and angle R? They're supplementary, and if they're supplementary and they're same side interior, then these lines are parallel. You with me? So I have one pair, so I know this is for sure. This is at least a trapezoid. Because PS is parallel to QR, or there's one pair of parallel sides. Now the next question is it isosceles? So what's true about an isosceles trapezoid? Good. Are these base angles congruent? Yep. 74 equals 74, and if I added 74 and 74, 144 and 106, 250, subtract that from 360. Did I add that wrong? 74, that would be an 8. Let's try this again. 148 plus 106. 254, subtract that from 360, and I get 106. So my base angles are congruent, which makes this also isosceles. So the answer is yes, and you have to back it. So it doesn't have to be exactly those words, but obviously you got to have enough information to prove it based on what you know about these objects. Okay, next one says, give the most specific name for the quadrilateral and explain your reasoning. So what do we know about this 4-sided figure? Chris? 2 pairs of consecutive sides, which makes this? Okay, good. So it's a kite because 2 pairs of consecutive sides are congruent. This one says, give the most specific name for the quadrilateral. Again, explain your reasoning. So now let's look at what pieces of information I know about this. So what's one thing you could tell me based on this shape? It's got 1 pair of parallel sides, right? What else do you know? What's true about my diagonals? They do not bisect, right? And are they congruent? They are not congruent, nor do they bisect. So if they if they were congruent, I could actually say that this was a isosceles trapezoid, right? If they're not bisected and they're not congruent, what do I know about this shape? It's just a trapezoid. So I only have 1 pair of parallel, and the diagonals are not congruent. this example, or example 6 says, give the most specific name for the quadrilateral and explain your reasoning. So if you look at the quadrilateral that's drawn, it gives you specific information about these pair of opposite sides, that they are congruent. You have a measurement over here, but nothing to match it on this side. And then you've got this one diagonal that's being bisected. So I don't know anything about the other length of the diagonal, and I don't know anything about the length of the angles. So initially when we went over this in class, we had said that these two triangles would be congruent, making the 9 go on the other side. But we basically, if you look at those triangles, don't have enough information to prove that they're congruent. We've got 2 pairs of congruent sides. So this would be my reflexive side that's shared by both, this side here, and then this side's definitely congruent to this side, but we don't know anything about the angle in between them or about the third side. So this is not enough information to prove that they are congruent, which means that the only thing I know about this is that I've got one pair of parallel sides and that one diagonal that's bisected. So this isn't enough to prove anything other than this is a quadrilateral, which is just that 4-sided figure.